Before covering the homework problem, I want to go over some of the definitions from this module. The first definition is pressure. Fluids exert forces on the walls of their container and on other parts of the fluid. Pressure is the force-to-area ratio, F over A. The second definition I want to go over is fluids. A fluid is a substance that flows. Both gases and liquids are fluids. Relating to problem 15.20 is buoyancy. Now, for this definition, a ship floats because of buoyancy. You'll learn to use Archimedes' principle to calculate the buoyant force as the weight of the displaced fluid. We're going to be going over problem 15.20, and the context of the question is you and your friends are playing in the swimming pool with a 50 centimeter diameter beach ball. And the question is asking us how much force would be needed to push the ball completely underwater. So for this problem, we're going to need to figure out what the downward force is on the ball, and that's going to equal the buoyant force. So the equation that we're going to use is buoyant force equals the mass of water times gravity. Now the mass of water is represented by mw, and g represents the acceleration of gravity, the gravitational constant, which is 9.8 meters per second squared. So over here we have our equation that we're going to be using, which is the buoyant force, and we're going to plug in the density of water, which is going to be rho of W, and then we're going to be plugging in this equation 4 over 3 pi radius cubed to represent the volume of the ball, and then that's going to be multiplied by g, the gravitational constant. So the first step of this problem is that we're going to calculate the radius of the ball. So we take r, which is going to equal diameter divided by 2, and the diameter we're given is 50 centimeters, and we're going to divide that by 2 and end up getting 25 centimeters. And then we're going to divide that by 100 centimeters to convert it to meters and end up with a radius of 0.25 meters. Now the second part of this problem is that we're going to calculate the force required to push the ball completely underwater, so the final step. And what we're going to do is we're going to substitute rho of W with 1,000 kilometers per meter cubed, and then we're going to substitute 0.25 meters for the radius. And our final equation we're going to be solving is buoyant force equals 1,000 kilometers per meter cubed times 4 over 3 pi 0.25 cubed times 9.8 meters per second squared. And we end up, after calculating, we get 641.4 newtons. And because the problem is asking for two significant figures based off of the 50 centimeters diameter that we're given, the final answer ends up being 640 newtons.